Since its inception in 1947, Formula One has used a variety of engine regulations. Formulas limiting engine capacity had been used in Grand Prix racing on a regular basis since after World War I. The engine formulae are divided according to era. Operation: Formula One currently uses 1.6-litre 4-stroke turbocharged 90-degree V6 reciprocating engines. The power a Formula One engine produces is generated by operating at a very high rotational speed, up to 15,000 revolutions per minute. This contrasts with road car engines of a similar size which typically operate at less than 6,000 RPMs. The basic configuration of a naturally aspirated Formula One engine had not been greatly modified since the 1967 Cosworth DFV, and the mean effective pressure had stayed at around 14 bar MeP. Until the mid-1980s, Formula One engines were limited to around 12,000 RPMs due to the traditional metal valve springs used to close the valves. The speed required to operate the engine valves at a higher RPM called for ever stiffer springs, which increased the power loss to drive the camshaft and the valves to the point where the loss nearly offset the power gain through the increase in RPM. They were replaced by pneumatic valve springs introduced by Renault, which inherently have a rising rate that allowed them to have extremely high spring rate at larger valve strokes without much increasing the driving power requirements at smaller strokes, thus lowering the overall power loss. Since the 1990s, all Formula One engine manufacturers used pneumatic valve springs with the pressurized air, allowing engines to reach speeds of nearly 20,000 RPM. Short-stroke engine: Formula One engines use short-stroke engines. These engines are common in racing motorcycles and street bikes. The bore is the diameter of the cylinder in the engine block, and the stroke is the distance the piston travels from top dead center to bottom dead center inside the cylinder. To operate at high engine speeds, the stroke must be relatively short to prevent catastrophic failure. This is usually connecting rod failure, as the rod is under very large stresses at these speeds. Having a short stroke means that a relatively large bore is required to make the 2.4-litre engine displacement. This results in a less efficient combustion stroke, especially at lower RPM. The stroke of a Formula One engine is approximately 39.7 ohm, less than half the bore diameter, what is known as an over-square configuration. In addition to the use of pneumatic valve springs, a Formula One engine's high RPM output has been made possible due to advances in metallurgy and design, allowing lighter pistons and connecting rods to withstand the accelerations necessary to attain such high speeds, also by narrowing the connecting rod ends, allowing for narrower main bearings. This allows for higher RPM with less bearing-damaging heat build-up. For each stroke, the piston goes from a null speed to almost 2 times the mean speed, then back to zero. This will occur 4 times for each of the 4 strokes in the cycle. Maximum piston acceleration occurs at top dead center and is in the region of 95,000 ams2, about 10,000 times standard gravity or 10,000 ag. History: Formula One engines have come through a variety of regulations, manufacturers and configurations through the years. 1947 to 1953, this era used pre-war Voiture engine regulations, with 4.5 L atmospheric and 1.5 L supercharged engines. The Indianapolis 500 used pre-war Grand Prix regulations, with 4.5 L atmospheric and 3.0 L supercharged engines. The power range was up to 425 HP. In 1952 and 1953, the World Drivers' Championship was run to Formula 2 regulations, but the existing Formula 1 regulations remained in force and a number of Formula 1 races were still held in those years. 1954 to 1960, engine size was reduced to 2.5 L 750 cc. Supercharged cars were allowed, but no constructor built one for the World Championship. The Indianapolis 500 continued to use old pre-war regulations. The power range was up to 290 HP, 1961 to 1965. Introduced in 1961 amidst some criticism, the new reduced engine 1.50 L formula took control of F1 just as every team and manufacturer switched from front to mid-engined cars. Although these were initially underpowered, 5 years later average power had increased by nearly 50% and lap times were better than in 1960. The old 2.50L formula had been retained for international formula racing, but this didn't achieve much success until the introduction of the Tasman series in Australia and New Zealand during the winter season, leaving the 1.5L cars as the fastest single-seaters in Europe during this time. The power range was between 150 HP and 225 HP. 1966 Euro 1986. In 1966, with sports cars capable of outrunning Formula One cars thanks to much larger and more powerful engines, the FIA increased engine capacity to 3.0L atmospheric and 1.5L compressed engines. Although a few manufacturers had been clamoring for bigger engines, the transition wasn't smooth and 1966 was a transitional year, with 2.0L versions of the Bmw and Coventry Climax V8 engines being used by several entrants. The appearance of the standard-produced Cosworth DFV in 1967 made it possible for small manufacturers to join the series with a chassis designed in-house. Compression devices were allowed for the first time since 1960. But it wasn't until 1977 until a company actually had the finance and interest of building one, when Renault debuted their new Gordini V6 Turbo at the British Grand Prix at Silverstone that year. It was in 1980 that Renault proved that turbocharging was the way to go in order to stay competitive in Formula One. This engine had a considerable power advantage against the Ford Cosworth DFE, Ferrari and Alfa Romeo naturally aspirated engines. Following this, Ferrari introduced their all-new turbocharged engine in 1981. Following these developments, Brabham owner Bernie Ecclestone managed to get BMW to make the team turbocharged inline-four engines from 1982 onwards. And in 1983, Alfa Romeo made a turbocharged V8 engine, and in the same year and following years, Honda, Porsche, Ford Cosworth and other smaller companies made turbocharged engines, mostly twin-turbocharged V6s. By the midpoint of 1985, every competing team had a turbocharged engine in their car. And by 1986, the power figures were becoming quite crazy. All of the engines had unrestricted turbo boosting qualifying, where they were developing 1,350 plus HP at 5.5 bar boost. These engines and gearboxes would only last about 2 to 3 laps, and for the race, the turbocharger's boost was restricted to ensure engine reliability. But the engine still produced 950-1000 HP during the race. The power range from 1966 to 1986 was between 285 HP to 500 HP, turbos 500 HP to 900 HP in race, in qualifying up to 1,300 HP. Following their experiences at Indianapolis, in 1971 Lotus made a few unsuccessful experiments with a Pratt & Whitney turbine fitted to chassis which had also 4WD. 1987 Euro 1988, following the turbo domination, forced induction was allowed for 2 seasons before its eventual ban. The FIA regulations limited boost pressure to 4 bar in qualifying in 1987 for 1.5L turbo, and allowed a bigger 3.5L formula. These seasons were still dominated by turbocharged engines, the Honda RA167 EV6 supplying Nelson Piquet winning the 1987 Formula One season on a Williams, also winning the Constructors' Championship, followed by TAG Porsche P01 V6 in McLaren, then Honda again with the previous RA166E for Lotus, then Ferrari's own 033D V6. The rest of the grid was powered by the 4GBA V6 turbo with Benetton, then the only naturally aspirated engine, the DFV-derived Ford Cosworth DFZ 3.5L V8 outputting 575 HP in Tyrrell, Lola, AGS, March and Colony. The BMW M12/13 inline-4 was found in Brabham's BT55 tilted almost horizontally, and in upright position under the Megatron brand in Arrows and Ligier, producing 900 bhp at 3.8 bar in race. Zaxpeed was building its own turbo inline-4, Alfa Romeo was to power the Ligiers with an inline-4, but the deal fell through after initial testing had been carried out. Alfa was still represented by its old 890T V8 used by Osella, and Minardi was powered by a Motori Moderni 5.6. The 1988 Formula One season was again dominated by turbocharged engines limited to 2.5 bar and Honda with its RA168e Turbo V6 producing 675 HP at 12,500 RPMs in qualifying, this time with McLaren drivers Ayrton Senna and Alain Prost winning all the Grand Prix except one won by Ferrari with its 033 EV6 with about 690 HP at 12,800 RPMs in qualifying. Just behind, Ford introduced its DFR 3.5L V8 producing 620 HP at 11,000 RPMs for Benetton, and the Megatron BMW M12/13 was still powering arrows ahead of the Lotus Honda. Judd introduced its CV 3.5L V8 for March, Williams and Ligier, and the rest of the grid was mainly using previous year's Ford Cosworth DFZ except Zax Speed and the Alfa Romeo Forcella. 1989 a Euro 1994. Turbochargers were banned from the 1989 Formula One season, leaving only a naturally aspirated 3.5L Formula. Honda was still dominant with their RA109E72 a degree V10 giving 675 HP at 13,000 RPMs on McLaren cars, enabling Prost to win the championship in front of his teammate Senna. Behind were the Renault RS01 powered Williams, a 67 a degree V10 giving 650 HP at 14,300 RPMs. Ferrari with its 035/565 a degree V12 giving 660 HP at 13,000 RPMs. Behind, the grid was powered mainly by Ford Cosworth DFR 5.8 giving 620 HP at 10,750 RPMs except for a few Judd Co V8 in Lotus, Brabham and Euro Brune cars, and two oddballs, the 620 HP Lamborghini 351280 a degree V12 powering Lola, and the 560 HP Yamaha OX8875 a degree V8 in Zax Speed cars. Ford started to try its new design, the 75 a degree V8 HBA1 with Benetton. The 1990 Formula One season was again dominated by Honda in McLarens with the 690 HP at 13,000 RPMs RA100E powering Ayrton Senna and Gerhard Berger ahead of the 680 HP at 12,750 RPMs Ferrari Typo 036 of Alain Prost and Nigel Mansell. Behind them the Ford HBA4 for Benetton and Renault RS2 for Williams with 660 HP at 12,800 RPMs were leading the pack powered by Ford DFR and Judd Co engines. The exceptions were the better Lamborghini 3512 in Lola and Lotus, and the new Judd EV76 a degree V8 giving 640 HP at 12,500 RPMs in Leighton House and Brabham cars. The two new contenders were the Life which built for themselves an F35W12 with 3 4-cylinders Banks at 60 a degree, and Subaru giving Colony a 1235 flat 12 from Motori Moderni. Honda was still leading the 1991 Formula One season in Senna's McLaren with a 710 HP at 13,000 RPM 60 a degree V12 RA121E, just ahead of the Renault RS3 powered Williams benefiting from 700 HP at 12,500 RPMs. Ferrari was behind with its Typo 037, a new 65 a degree V12 giving 710 HP at 13,800 RPMs also powering Minardi, just ahead the Ford HBA46 in Benetton and Jordan cars. Behind, Tyrrell was using the previous Honda RA109E, Judd introduced its new GV with Dallara leaving the previous EV to Lotus, Yamaha were giving it 660 HP OX9970 a degree V12 to Brabham, Lamborghini engines were used by Modena and Ligier. Ilmor introduced its LH10, a 680 HP at 13,000 RPMs V10 which eventually became the Mercedes with Leighton House and Porsche sourced a little successful 3512 V12 to footwork arrows. The rest of the field was Ford DFR powered. By the end of the 1994 season, Ferrari's 043 was putting out 820 HP at 15,800 RPMs, 1995 a Euro 2005. This era used a 3.0L formula, with a power range between 650 HP and 950 HP. Renault was the dominant engine supplier between 1990 and 1997, winning 5 world championships with Williams and Benetton. From 1998 to 2000 it was Mercedes power that ruled, giving Mika Hakkinen KKINEN 2 world championships. Ferrari gradually got better with their engine. For 1996, they changed from their traditional V12 engine to a smaller and lighter V10 engine. They preferred reliability to power, losing out to Mercedes in terms of outright power initially. At the 1998 Japanese GP, Ferrari's 047D engine spec was said to produce over 800 bhp. From 2000 they were never short of power nor reliability. BMW started supplying their engines to Williams from 2000. In the first season, the engine was very reliable though slightly short of power compared to Ferrari and Mercedes units. BMW went straight forward with its engine development. The P81, used during the 2001 season, was able to hit 17,810 rpms. Unfortunately, reliability was a big issue with several blow-ups during the season. The BMW P82, the engine used by the BMW Williams F1 team in 2002, had hit a peak speed of 19,050 revolutions a minute in its final evolutionary stage. It was also the first engine in the 3.0-litre V10 era to break through the 19,000 rpms wall, during 2002 Austria Grand Prix qualifying. BMW's P83 engine used in 2003 season managed an impressive 19,200 rpms and cleared the 900 bhp mark and weighs less than 200 lb. In 2005, the 3.0L V10 engine was permitted no more than 5 valves per cylinder. Also, the FIA introduced new regulations limiting each car to 1 engine per 2 Grand Prix weekends, putting the emphasis on increased reliability and decreased power output. BMW and Mercedes engines had about 930 bhp in this season. Renault, Honda, Toyota and Ferrari had about 900 bhp. 2006 Euro 2013, for 2006, the engines had to be 90 degree V8 of 2.4 litres maximum capacity with a 98 ohm maximum circular bore, which implies a 39.8 ohm stroke at maximum bore. They had to have 2 circular inlet and exhaust valves per cylinder, be normally aspirated and have a 95 kg minimum weight. The previous year's engines with a rev limiter were permitted for 2006 and 2007 for teams who were unable to acquire a V8 engine, with Scuderia Toro Rosso using a Cosworth V10, after Red Bull's takeover of the former Minardi team did not include the new engines. Pre-cooling air before it enters the cylinders, injection of any substance other than air and fuel into the cylinders, variable geometry intake and exhaust systems, and variable valve timing were forbidden. Each cylinder could have only 1 fuel injector and a single plug spark ignition. Separate starting devices were used to start engines in the pits and on the grid. The crankcase and cylinder block had to be made of cast or wrought aluminium alloys. The crankshaft and camshafts had to be made from an iron alloy, pistons from an aluminium alloy and valves from alloys based on iron, nickel, cobalt or titanium. These restrictions were in place to reduce development costs on the engines. The reduction in capacity was designed to give a power reduction of around 20% from the 3-litre engines, to reduce the increasing speeds of Formula One cars. Despite this, in many cases, performance of the car improved. In 2006 Toyota F1 announced an approximate 740 bhp output at 19,000 rpms for its new RVX06 engine, but real figures are of course difficult to obtain. The engine specification was frozen in 2007 to keep development costs down. The engines which were used in the 2006 Japanese Grand Prix were used for the 2007 and 2008 seasons and they were limited to 19,000 rpms. In 2009 the limit was reduced to 18,000 rpms with each driver allowed to use a maximum of 8 engines over the season. Any driver needing an additional engine is penalized 10 places on the starting grid for the first race the engine is used. This increases the importance of reliability, although the effect is only seen towards the end of the season. certain design changes intended to improve engine reliability may be carried out with permission from the FIA. This has led to some engine manufacturers, notably Ferrari and Mercedes, exploiting this ability by making design changes which not only improve reliability, but also boost engine power output as a side effect. As the Mercedes engine was proven to be the strongest, re-equalizations of engines were allowed by the FIA to allow other manufacturers to match the power. 2009 saw the exit of Honda from Formula One. The team was acquired by Ross Brawn, creating Brawn GP and the BGP001. With the absence of the Honda engine, Brawn GP retrofitted the Mercedes engine to the BGP001 chassis. The newly branded team won both the Constructors' Championship and the Drivers' Championship from better-known and better-established contenders Ferrari, McLaren, Mercedes, and Renault. Cosworth, absent since the 2006 season, returned in 2010. New teams Lotus Racing, HRT, and Virgin Racing, along with the established Williams, used this engine. The season also saw the withdrawal of the BMW and Toyota engines, as the car companies withdrew from Formula One due to the recession. 2014, the FIA announced the intention to change the 2.4-litre V8 engines to 1.6-litre V6 turbo engines including energy recovery systems and containing fuel flow restrictions, in order to make Formula One more environmentally aware and to attract more commercial partners for 2014. The engines are limited to 15,000 RPMs, but rarely exceed 12,000 RPMs during Grand Prix due to the new reliability and fuel flow restrictions. Of the previous suppliers, only Mercedes, Ferrari and Renault produced engines to the new formula in 2014. Honda is set to return in 2015 with their own engine, partnering Mclaren who used Mercedes power for the 2014 season. The new formula reintroduced turbocharged engines, which last appeared in 1988. These have their efficiency improved by turbo compounding and introduce more energy recovery systems with power to be harvested from the brakes and exhaust gases. The original proposal for four-cylinder turbocharged engines was not welcomed by the racing teams, in particular Ferrari. Adrian Newey stated during the 2011 European Grand Prix that the change to a V6 enables teams to carry the engine as a stressed member, whereas an inline-four would have required a space frame. A compromise was reached to adopt V6 turbocharged engines instead. Engine specification progression, note. World Championship Grand Prix wins by engine manufacturer, figures correct as of the end of the 2014 Russian Grand Prix. Bold indicate that this engine manufacturer has competed in Formula One in the 2014 season. The Indianapolis 500 was part of the World Drivers' Championship from 1950 to 1960. References. External links, Formula One engines in-depth article covering facts, evolution and tech specs of F1 engines, race car engineering F1 engines, Viva F1 engine cycle statistics,